All right, another example of a Limacon graph here. We have 1.5 plus 1.5 sine theta. I'm going to do the same thing as our first graph, and I'm going to graph this in the xy coordinate plane first. And this is just for your use, so like it has to be as accurate or as inaccurate as you guys want it to be. But the real point of doing this is just to get, a couple points to put on our graph. So my mid line's up at 1.5. This is a sine curve. So I'm going to have these guys. So I'm going to label a couple on here. We'll have 0, 1.5, pi over 2, 3, pi, 1.5 again. We've got a 0 here. So that means we'll have a point on the pole. This is at 3 pi over 2 and 2 pi. All right, so I'm going to graph these on this grid. My max point is 3, so I could rescale. My graph's got a little cut off here, but I think I'll leave it. So 0, 1.5, pi over 2, 3, pi, 1.5, 3 pi over 2, 0, and then we're back at the start. So if I'm not sure what's going on with this graph, then I will, for myself, just check another point to help us out. So this is a sine graph, so we also know that, hopefully, and you can check, sine graphs usually have this pi over 2 symmetry, and for what we've seen from Limacons, we do pretty much know this to be true. But if you check for pi over 2 symmetry for this one, pi over 2 symmetry is like the y-axis up here. It would be checking a point that's across. So like a point we could check would be negative r negative theta. And even just looking at the equation, if I put a negative r in, I don't think that would work to sub in. But like another option for how we could write that point would be r pi minus theta. And this would actually work for a check. You guys don't have to do this check like I was saying before, but I really quickly want to show this just to bring back all the memories of the great things we did earlier in the year. But here's my original equation. If I sub in that other point, pi minus theta, to simplify this, we would use the sum and difference identity. Sine pi cosine theta minus cosine pi sine theta. Sine of pi is 0, so that guy's gone. Cosine pi is -1, so this turns into positive sine, so plus 1.5 sine. So that would be the check that works out, which again is a little bit tricky. Like I was saying before, negative r, negative theta would be another way to write that point. But if I subbed these into this equation, it would not turn into the original. It doesn't mean that there's not theta equals pi over 2 symmetry. So just pointing that out as an example. But again, trying one more point on here, like another point for sine would be pi over 6 is a nice one. So it'd be 1.5, which is like 3 over 2. And 3/2 times sine of pi over 6 is 1/2. So this would turn into, after we simplify, pen's going a little wacky here, 9/4. And maybe a negative pi over 6 just for good measure here. Would be almost the same, just negative 1/2 up there. So this would be 6/4 minus 3, 3/4. All right, so 2 more points I can throw over there. That would be pi over 6 and then 2.25. And remember, theta equals pi over 2 symmetry, so I automatically get that point. And and negative pi over 6, 3/4. So this graph actually has a shape that looks like a heart. And that's where the name for this graph came from, and it is called a cardioid. And this happens for limacons when A is equal to B. Now, the reason also I drew out our rectangular forms, for these looped limacons, we had negative values in our xy coordinate plane. And that's where the loop came from, right? Instead of going like into quadrants 1 and 2, it jumped back across, or 1 and 4, it jumped back and made that loop. Here, I never got negative values in the coordinate plane. So whenever I'm in quadrant 1, I'm in quadrant 1. Angles in quadrant 2 are in quadrant 2, right? It's just different values for those. So some things to think about to help you figure out what's what in the limacon world. All right, I want you guys to try out these other ones, the next two, 4 pi over 3, or 4 plus 3 cosine, which we already graphed in the warm-up, but now it's a cosine, and 5 plus 2 sine. Graph these on here. They are other types of limacons. I will post my answer key so you can see the name for the limacons there and get that shape. But use your calculator to help you out so you can see what's going on for those. And then I'll do another video for this guy down here, which is a rose.